Hello, my name is ALZAHIER and I'm going to explain about what is green theorem used for. Green theorem is mainly used for the integration of the line combined with a curved plane. This theorem shows the relationship between a line integral and a surface integral. It is related to many theorems such as Gauss theorem and Stokes theorem. Okay, next I'm going to explain how to understand the green theorem. Okay, the fxy is represent the function for the vector field. The r is the region in the xy plane, and the c is the boundary of r oriented counterclockwise. The line integral f.dr is for measuring the rotation. Okay, green theorem states that the line integral of f around the boundary of r is the same as the double integral of curl of f within r. So as we can see, this is the formula for the green theorem, which is from the f.dr for measuring the rotation. It is conventional to think of counterclockwise rotation as being positive, in which case c should be oriented counterclockwise.
So Assalamualaikum, my name is NAZMI. To continue to understanding about the green theorems is, imagine chopping up the region R with a line straight down the middle, giving two sub-regions R1 and R2. Name the boundaries of these two regions C1 and C2. So this means the sum of our two integrals is the same as just going around the full boundary C as the below. So next, imagine chopping off the region R into many tiny pieces, R1 until Rn. Orient all of the boundaries C1 until Cn counterclockwise and integrate the function f over each one. So this means adding up the line integrals along the tiny boundaries of the pieces will give the same result as just integrating across the full region as the below. So as you consider smaller and smaller pieces, the line integral around each tiny piece can be approximated using two-dimensional curve as the below. Integral around a tiny piece of RK, point in RK, area of RK. Next, adding up these little bits of curve using a double integral over R and applying the fact that the sum of the line integrals cancels out along interior cuts, you get the green theorem. So next we go to the engineering application.
My name is MOHAMAD SHAHIZAQT bin AZMAN. My material number is B02211065. I will discuss about engineering application solved by using green theorem. Okay, for application 1, in electrostatic, the electric field lines cannot form any closed loops. However, in the electrical field lines, electrodynamic form closed loops, which is entirely based on green theorem, such as relation between integral and differential form of Maxwell equation and the energy of steady current. Therefore, by using green theorem, the integral is equivalent. We know the equation is integral C bracket y plus exponent square root infinity dx plus bracket 2x plus cos bracket y power of 2 dy. C is the boundary of the region enclosed by the parabola. We know that y equals s power of 2 and s equal y power of 2. For solution, integral y plus exponent square root s ds plus 2s plus cos y power of 2. We know that the formula of integral green theorem is integral bracket del g over del s minus del f over del y dA. For f sy equal y plus exponent square root s. For g sy equal to s plus cos y power of 2. For del f over del y equal y plus exponent square root s. And we integrate that we differentiate respect to y. We got 1. For del g over del s equal to s plus cos y over y power of 2, and with respect to s we got 2. After that, we just replace it, which is integrate 2 minus 1 dy ds. We got limits for ds 0 to 1 and limits for dy x power of 2 to square root x, and we integrate y. After that, we need to put on y, which is limits 0 to 1. We replace y with square root x minus s power of 2 ds, and we got s power 1 over 2 minus s power of 2 ds. After that, we need to integrate s, so we got s power of 3 over 2 over 3 over 2 minus s power of 3 over 3, and for limits there is 0 to 1, and we need to replace s with limit, which is we got 2 bracket 1 power 3 over 2 and over 3 minus brackets 1 power of 3 over 3, and lastly we got the final answer is 1 over 3. Okay, for next present I will pass to the max, which is Abdul.
Assalamualaikum and hi, my name is Abdul bin ZAMRI. So for this figure, from the equation given, which is x equal to y square and y equal to x square, we enter the equation in the Desmos applications. Then we will get two curves as a result, x curve and y curve. Curve for x is horizontally and curve for y is vertically. Both of the curve is smile shape. For the next one, we will be calculating the limit. For x, we have to see the intersection between curve x and curve y. So curve x is 0 to 1. For y, we have to see the upper and lower curve from the intersection, where we will get y equal to x square for lower part and y equal to square root of x for upper. The limit is for x 0 to 1 and for y is x square to square root of x. Thank you so much.
Assalamualaikum. My name is Muhammad FIRDAUS bin ZAHARI and my metric number is B022110017, and I'm gonna explain how to use green theorem for this question. Firstly, the formula of green theorem is double integral delta g respect to x minus delta f respect to y dA, and we must find a value for fxy and gxy. For fxy, we can get this value from this equation, that is square root 1 plus x over x power of 3 dx, and for gxy is 2xy dy. We must differentiate the both of them. So for fxy is after we differentiate delta f respect to y, the answer is 0, and for gxy, after we differentiate delta g respect to x, we get the answer is 2y. And for equation for green theorem, we must get the limit for y-axis and x-axis. So for the x-axis is 0 to 1, and for y-axis is 0 to 3x. We can get this limit from the graph. And formula delta g respect to s minus delta f respect to y, we get it before, so 2y minus 0 dy dx. So we get this full equation. After that, we integrate 2y, we get y power of 2 dx. So after that, we substitute the 3x into y power of 2, and we get a 9 x power of 2. After that, we integrate 9 x power of 2 dx, and then we get 9x power of 3 per 3, and then we substitute number 1 into x. So after that we get the answer is 3. Thank you.
Okay, for the graph, from the data given from the question, we can get the x is 1, 0, 1, 1, 0, and y is 0, 0, 3, 0. We put it into the MATLAB software to simulate the graph, which we plot xy. We can get this graph, which is in the shape of triangle. Okay, I'm going to continue to explaining about the graph to get the limit for the equation above. So from the question we can get the coordinate for the xy plane, which is 0, 0, 1, 0 and 1, 3. Okay, when we put it into the graph, we can get a graph in the shape of a rectangle. Okay, for the y-axis, which is 3, 0 to 3, and which for the x-axis is from 0 to 1. So it will be in the shape of triangle. Okay, to get the limit, we need to see from the x-axis and the y-axis. As for the x-axis, it is from 0 to 1. And for the y-axis, we can see after we plot the line from the middle, which is from 0 to the from 0 to the gradient of this triangle, which is we need to use the formula is for gradient, which is y equal to mx plus c. So we put the coordinate for x1 and y1 and x2 and y2. x1 y1 is 0, 0, x2 y2 is 1, 3. When we put into the formula for gradient, we get m equal to 3, and we put back into y equal to mx and by c, we get the c equal to 0, and then we put all the data we get, which is m equal to 3 and c equal to 0 into y equal to mx plus c, we get y equal to 3x. So for the limit for the y, we can see is from 0 to 3x. Okay, for the x we can get from 0 to 1. For the y is 0 to 3x.